scheduled?
P1 is first, followed by
P1 and P2. Yeah, we'll schedule these two. Next, scheduled program. What will happen there? Usually, what is there first in the queue, right? It is first come, first serve. P1 is first, so P1 will be scheduled, default. And up to here, it's fine. Now, what about the remarks? What will happen here? Remarks. What to write there? What do you write? So when we assume like the time slicing time is 10 milliseconds. 10 milliseconds uh, for time slicing. Let us assume. Now when this P1 has to get preempted? Up to here there is no change in the story, correct? Up to here there is no change. Now next what should happen? Time is from 10. Okay. Now P2 is scheduled first, followed by P1. So P2 is scheduled here. Next. What will happen here? P2 is 10 or how much it is? 20. From here the story will change slightly. What will happen now? What to write now? If you can tell me, you understood this concept. So which are there in scheduling list? Which one is first, P1 or P2? See, it's like there is given a note here. Each cycle contains a burst. We are doing in a cyclic manner. Cycle means what? When one pedal is down, other pedal is up. When you cycle again, next cycle, the other pedal is out. Right pedal is up, left pedal is down. So it's vice versa. So when you do P1, P2, P1, P2, it will be happening. So it's like pedaling. P1 we give, P2 will come. Further we get P1. If it is not completed, we'll get in cyclic fashion. If we complete that, the same will repeat. Correct? After P2 has to get turn. So P1 should get the turn, P1 followed by P2, and here it's what? P1. Now what will happen? Here it is. Whether P1 will start the IO process. See this here. P1 starts IO at 25. Can we start here or not yet?
not yet.
Not yet. So what to write? What's the comment now? So P1 is preempted at
30.
30 milliseconds. Correct. So P1 is preempted at 30 milliseconds. So it's not completed because 30 milliseconds. Or we can write like this. Only 20 we did. Other 10 we not did. Okay. So parallelly based on this, you should draw the table also. Okay. Fine. Now let us see here further. Next, what to do? So it is 30. Okay. Next, P2 and P1. So P2 is scheduled. What will happen for P2? Starts IO at what? Where to start the IO? P2. Already 10 we completed. How much left out? 5 left out. So 30 plus 5, how much?
35 milliseconds.
35 milliseconds. So P2 is out now because it started IO, it's done. 35 milliseconds. Only P2 is left out. Only P2 is scheduled. Sorry, not P2. P1 is done. P1 is left out, and only P1 is there. Now, what to do now? So 10, 10. Now P1 is preempted at what? Or directly you can do start the IO. Right. Can we write this? Correct? What will happen here? 45 milliseconds. Nothing will be there, nothing will be there. And then the CPU is correct. Any doubt in this? Can you draw the table? Like this. Can you draw this? Can you try with this? Then you are able to understand time sharing process. Okay. You try that, you do it. Okay. So this one you note down, or you just take this question, this much only, which change it, and then you try it, how it can be done. Fine. Shall we go further? Okay. So the explanation of this is given here. So P1 is using CPU, all that. We discussed everything. The same thing is given here. I will share it to you slides. You can go through it. Same explanation of that. Okay. Now, this is something about swapping programs. Something with swapping of programs. So what is swapping? What is swapping? I take yours, you take mine. Both of your friends are available. What you think of? You think of I take yours, you take my load, or I will write your work, you do my work. So that's what swapping. Once what happened, like one of them, like Swamiji or something will be there, right? They asked, okay, all of you feel like you have a lot of big problems. You all know that maybe, right? You feel like you have a lot of problems in your life. You're struggling in your life. Everyone told, yes, sir, we are struggling, we are not happy, all that. And then what he told is, okay, fine, you do one thing, then all of you can, I'll give permission for you, I'll give something magic, I'll do it, and I'll make sure that you can exchange your problems. Then they went on around to their friends to find out their problems. Okay. Because if they want to swap it or if they want to exchange it, it is possible. They told, okay, I'll make it permitted, you can exchange it. And they went and discussed. And later they came back and told, like, no, sir, no, Swamiji, we will keep our problems with us. Let their problems be with them. I will not exchange with them. Okay, we will feel like our problem is bigger than others. But everyone have their own problems. Fine? Yeah. So this what swapping here. So why we have to introduce swapping here is, if you look at this diagram, there is one drawback in this diagram. Okay. So can anyone figure out what is the drawback in this diagram? So what's the drawback in the diagram and what's the fault? Everything looks fine, but there is something missing out. So there is something free. It is left free. It's not used at all. So what was that? If you look there, CPU activity from 45 milliseconds till 125 milliseconds, there is no CPU activity. Do you agree with me?
Yes, sir.
So that's why what they did is, okay, fine, the CPU is not used by you, I'll use it sometime. So like that, they have swapped it. I'll show you the example of that. Okay. So based on this drawback or based on this disadvantage, the CPU is idle after 45 milliseconds, so it is not used. So why can't we bring